Okay, so guidelines. Number 1, work with each side of the equation independently. Start with the most complicated side. When possible, factor. And remember, there's 2 ways to factor. We can factor something out, or we can, is it all right if I say bubble? You know,
Is foil a foil?
well, it's not foiling, it's actually unfoiling.
What is it actually called?
Factoring. So there is no special word for it, it's just making the 2 bubbles. Think of double bubble like the gum. Okay. Number 3, separate single term quotients into 2 terms. And let me show you what I mean. I mean, take something like this, a plus b over c. Now, this only works when you have 2 terms in the numerator. You can't do this when you have 2 terms in the denominator. And I have a little slang word for this too. What does that look like? Crunch, crunch, crunch. Crunch. No, it looks like a type of food.
A pretzel.
Pretzel, yeah. It's a pretzel. So we call this pretzeling. Does it? Well, a heart isn't food. We're not going to eat hearts. Okay. What is called is separating a single term quotient into 2 terms. So what does this actually allow you to do? What it allows you to do is rewrite the fraction as a over c plus b over c. Okay, called pretzeling because it's supposed to look like a pretzel. Maybe I'll bring pretzels someday for a little snack. Friday for the quiz, maybe. Combine fractions using LCD. So guys, when you run into a problem that you're either adding fractions or subtracting fractions, you're probably going to have to find an LCD, is what you're going to have to do. All right, off we go. Example 1. Verify that secant squared theta minus 1 over secant squared theta equals sine squared theta. Which side looks more complicated? Left or right? Okay. So we're going to work on this side. Okay, now, do you guys all have your orange sheets out? Squared theta minus 1 is the same as tangent squared? Okay, and we're trying again to prove that it equals sine squared. Okay, tangent squared. Tangent is sine over cosine divided by, and secant squared is 1 over cosine. Okay? And what can we do with this division bar, guys? Change it to multiply, right? So sine squared theta over cosine squared theta. Division bar changes to multiplication, and what do we do with this fraction? Times cosine squared theta. You can put it over 1. And what do you guys see we can do next? Cross cancel. Yep. And guess what we get?
Sine squared theta.
Yeah. So did either way work? Yeah. So remember I said these are like geometry proofs. Okay. So here we are. Here's what we want. Do we see the 2? Yeah. So that's a good thing. Now, what are we going to do with 1 minus cosine squared, Leah? Refers to the second row? Okay, Vanna White? Vanna? Can you point to what Leah is saying?
Yeah, which one?
Which one did you say, Leah?
Sine squared theta equals 1 minus cosine squared this one?
Yes, very good. So we have 1 minus cosine squared, so Leah wants to change it to sine squared. Thank you, Vanna. So we have 2 over sine squared. Okay. And we can write that as 2 over 1 times 1 over sine squared. And I know that's kind of the iffy, and I'm sorry, I changed the theta. I didn't mean to change the theta.
Sorry.
I know it's kind of funky to go from here to here, but 2 is in the numerator, sine squared is in the denominator. I separated it into 2 pieces. Why? Why did I separate it into 2 pieces? So what can we do with 1 over sine squared? The what? I don't have 2 terms on the top to pretzel. Can we look at the top row, guys? What's 1 over sine? Cosecant. So 1 over sine squared is cosecant squared x. Pa-pow. Same, same. That's pretty simplified. I would mess now with secant squared. So go to the top row. Secant is the same as what, Leah?
1 over cosine squared.
Yeah. So this secant squared we're going to write as 1 over cosine squared times negative sine squared over 1. Okay. All right. Then Jasmine, multiply the numerators. What do we get? Good. You did that so well, Jasmine. Do the denominators. What do you get? Okay. And Max, look at the top row. What is sine over cosine?
Tangent.
Yes. So because it's squared, it's going to be tangent squared x. And then don't forget, guys, we have the negative out in front. Yay. Did we make it? Yeah, we made it. Okay. You still having good fun right now? We have left cosecant x minus 1. We're going to stop on that side. We're going to go to the other side. Out of our guidelines, there's something we can do on the other side. So what out of the 4 guidelines that I gave you can we do on the other side? What'd you say? Pretzel. Rachel says pretzel, and Rachel is absolutely correct. Now make sure you pretzel correctly though. Rachel, you want to tell us what we get? What's on the top? 1 over sine x minus, and what's this one? I'm putting the negative out in front. Sine x over, is that what's on the bottom? Sine x over sine x. Now you keep saying 1. Do you want to make this into 1? Yeah, you do. Okay. So minus 1. Okay. And then Remy, look at the top row. 1 over sine is the same as? So cosecant x. Are we done? Can we be done now? Yeah, we can. Okay. Done.
Whoa, that was neat.
That's what happens when you get to work on both sides.